Hi everyone, welcome back to my channel. So this is another video of SIEM alerts and SIEM introduction, and our today's lecture is log aggregation and parsing. Let me complete this because I think it's not tick marked yet. Best method for those who do not want to manage agent software, it was agentless, and here the answer was blank. We have completed this. Yeah, okay. Log aggregation and parsing. So the first place where the generated logs are sent is to the aggregator, right? Logs are generated, it is transferred. See, these are the logs, they are transferred by any software or through some agent-less platforms via like connecting it to SSH or WMI. Then they are sent to the aggregator, right? They are sent to the aggregator. We can edit logs coming here before sending them to the destination. So here, once we have logs in the log aggregator, they can be edited, right? For example, if you want to get only the status code from a web server logs, we can filter the incoming logs and send only the desired part to the target, right? So here you can convert that raw data that is collected from the log into a proper format which you desire, right? So if you want only status code from web server logs, you can get them, right? So drop fields, this is the log aggregator. Here you can parse and then you can send this. So drop fields onto the parsed area to put them in their places, right? So here these are the fields that you can drop into the parsed area to put them into their places, right? Next is aggregator EPS. EPS is events per second. The formula is event upon time period of the seconds. For example, if the system received 1000 logs in 5 seconds, then the EPS would be 1000 by 5, that is time per second, event per second, sorry. So as the EPS value also increases, the aggregator and the storage area that should be used also increases, right? If events per second, so how many events have occurred per second is called as EPS. So if the EPS value is increased, the storage that is required to store that logs and the aggregator also increases. Scaling the aggregator. More than one aggregator can be added so that the incoming logs do not load the same aggregator each time. And sequential or random selection can be provided. So log aggregator, they could be different log aggregators, right? And the log coming to the aggregator is processed and then directed to the target. It's once processed by the log aggregator and it is directed towards the target. This process can be parsing, filtering, and enrichment, and then it reaches to the destination. In some cases, you need to edit the incoming log, right? For instance, while the date information you collect comes in the format DDMMYYY, it comes from a single source like this. You would want to convert that log, right? So you may need to convert UTC+2 incoming time information to like this. So enrichment can be done to increase the efficiency of the collected logs and to save time. Example enrichments could be adding geolocations, DNS, add or remove, right? The geolocation of specific IP can be found and added to that log. So the person who's viewing that log, it saves the time, right? So with DNS queries, the IP address of the domain can be found, or the IP can be found by doing reverse DNS, right? If you have DNS, you can find the IP. If you have domain name, if you have IP, you can find the domain name, right? This is like doing reverse DNS. So which one of the following is not the skill of the log aggregator? That is analysis, that is the work of an analyst. What is the EPS of a SIEM system that receives 15 this logs per minute? That's very easy. There are events per second, 151234 divided by 60 because it is events per second, right? This is 225. Very simple. Sorry. It was 15 5, 1, 2, 3, 4. Per minute is 60 seconds. 2, 5, 1, 2, 3. Okay. Moving forward to the next lecture, that is log storage. In our previous articles, we talked about logs and log aggregators. The next step is to store the incoming logs. Now you have got the logs, you have actually processed the logs in the format that you require using log aggregator. You've got the logs using log collecting agents or an agentless, let's say, software, right? So in our previous articles, we have talked about this. Now our next step is to store these incoming logs. So where you will actually store the logs that you have collected, it is with log aggregator, and then it is storage. So one of the common mistakes made in SIEM structure is to focus on storage size. Right, this is one of the very common mistakes that is made. High sized storage is important as well as the speed of accessing this data. For example, let's say we collect all the logs such as firewall, proxy, WF, etc. and imagine that it takes 15 minutes to make a search in these logs. In a situation where it is so difficult to access data, the studies will not be very productive. For this reason, the speed of data access should be considered in storage. Like how much earlier you want to access the data and the logs. How earlier you want to access that data and logs, right? So speed of accessing the data should be considered. When we look at a popular storage technology in the market, for example, MySQL, we see that it is focused on adding, editing, and deleting the data. But our focus is on indexing the data. How better you can index the data, how better you can search. We do not need to edit the stored log. Our purpose is to access the data as quickly as possible. For this, write once, read many. WORM. Only write once, but you can read many times. Based technology are more suitable to be used in SIEM, right? Because high size storage is important for better accessing the data, right? So this is write once, read many are this. You can understand the difference by pressing the search button in two different storage areas. So search, this is slow storage, right? It has taken a lot of time. This is fast storage. Right. So we would like to have this one. First query was quite slow, but it returns results instantly. While minor delays during investigation or processing of new incoming data, it is acceptable. Excessive delays can be risky, right? So is data update, change value, delete value, etc. very important for SIEM data storage? No, data updating is not necessary. Which one is the most important for SIEM storage? That is speed. Okay, moving forward is the alerting one. I think we should do this in the next video, so stay tuned. We'll do these two lectures in the next video. Do subscribe the channel too, and my bad was in the mistake in the calculation part. Forgive me for that. Thank you.